Hello everyone. For this tutorial video, I like to explain the process of implicit differentiation, which is known as that because you are deriving y in a more implicit manner, instead of y being a direct function of x like we have seen up to now. And implicit differentiation is usually done because y is used for other purposes than being a direct function of x. So y can be thought of in the context of these problems as a sort of separate x. Using a concrete example, we know that x squared plus y squared equals 9 gives us the equation of a circle with radius 3. If we attempt to solve for y directly, we would get y equals positive or negative square root of 9 minus x squared. And we know algebraically y is a function of x if and only if it has one specific value for all x's and not two or more like is the case here. So what we do instead is we differentiate both sides. The derivative of the first term on the left, x squared, is simply 2x. But the derivative of the second term, y of x squared, is more complicated. But if we use the chain rule and assume y of x is the inner function g, then this should logically mean the derivative is 2 times y times the derivative of y. And although we may now have taken care of the left-hand side in a more explicit manner, we are not done with the problem yet because we have to remember that we are differentiating the right-hand side as well, and the derivative of the right-hand side as a constant is 0. So now we get a more exact formula for the change of y by itself by subtracting the 2 times x and then dividing by the 2 times y, and we see the 2's cancel out in the numerator and denominator. And we should conclude that the derivative of y equals negative x over y. It is an unfortunate fact of life that when you do implicit differentiation problems, the derivative will more often than not involve y's as well as x's at the same time, and not simply x's. But although it may be unsettling at first, because of how we are used to the derivatives having values of x only, we will get accustomed to this change as we do more and more problems. Implicit differentiation is applied all the time in real-life problems, such as finding rates of change that are related to each other, as we will see when we actually do the problems later. In my next tutorial video, I like to talk about another advanced concept related to computing derivatives, namely something known as higher-order derivatives, which are derivatives of derivatives, derivatives of them, derivatives of them, derivatives of them, and so on. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.